Okay, let's go through this lesson real quick. Turn it to page 136. Let's find the getting started right here. Let's talk about more about geometric and arithmetic sequences today. On the getting started here, Rico owns a sporting goods store. He has agreed to donate $125 to the baseball team for their equipment fund. In addition, he will donate $18 for every home run the Centipedes hit during the season. And what they have here is the sequence shown represents the possible dollar amounts that Rico could donate. So if they hit no home runs this year, they're going to donate $125. Oh, come on. Hold on. There we go. So if they hit no home runs, we're going to start off with a $125 donation no matter what. Now, they start hitting home runs, and then we start increasing that by $18. So then he would donate $143 for one home run, and then another $18 for another home run, and then another $18 for another home run. And that pattern continues on down. Now, pay attention to the terms that I'm listing out. The terms are always one ahead of the number of home runs, and the reason why is because he's donating $125 no matter what. So we keep adding 18 to complete this table. So 179 plus 18, and I would show that 18 off the top side like I'm doing here, just to visually see that, again, you're remembering that you're adding $18 each time. 269, $18 one more time, $287. So after 9 home runs, Rico's going to be donating $287. Now, it says identify the type of sequence, and we have ourselves an arithmetic. And the reason why we know it's arithmetic is because we are adding 18. Adding and subtracting is arithmetic. Multiplying, dividing is geometric. And therefore, we have a common difference of 18. We complete the table, and then we can continue to calculate terms. We could find 10 home runs. We could find 11 home runs by just keep adding 18. Nothing too major on that. But that's going to get very annoying very quick, because what if you want to know how much Rico's going to donate after 30 home runs or 40 home runs? That table is going to get pretty long very quickly. So there's got to be a bit of a shorter way, and that's what today's lesson is going to be about, is finding a shortcut when we want to calculate something way down the road. So let's keep Rico in mind, and what we've been doing so far is what we call a recursive formula. You've been doing a recursive formula this entire topic, okay? All the recursive formula says is, if you know what the previous term is, keep adding that common difference to it, and that's what we were doing right up here. This is what we call a recursive formula. It was 215, we added 18. It was 233, we added 18. So as we keep adding that 18 on there to get to the next term, that is what we call a recursive formula, which is great if you know some of these terms, okay? But if I want to know the 50th term, well, the problem is I need to know what the 49th term is, and that's not very easy to see. So there's got to be an even better shortcut. So that's what the next page is going to be about, is what we call the explicit formula. All right, this is the explicit formula for an arithmetic sequence. Take this formula, and this is the one you want to kind of add into your library of things that we've been learning about this year. We're going to hit that a lot here today. You got to know what the first term of the sequence is, and you got to know what the common difference is. Those are things we all know pretty easily. Then after that, it's just going to be us mattering to use our calculator. So we're going to use that formula here to help us out. In this worked example they have, okay, we want to calculate the 93rd term. Great. And on that one, again, you got to know what the starting number is. You got to know what the common difference is. Well, on Rico, he was going to donate $125 no matter what. So that's why they put $125 right there. We knew what the common difference was, 18, because he's adding 18 each time. Now what the n is representing what term you want to find. we want to find the 93rd term, so that's why we put n as 93. After that, it's just merely going to our calculator and punching this into, say, Desmos, or just your calculator. 125 plus 18 times 92. 18 times 92 is 1,656 plus 125. Okay, he would donate $1,781 on a 93rd term, which technically means they've hit 92 home runs. And the reason why that, again, that term is one above the home run is because he's going to donate $125 no matter what. Okay, so from here, we're going to use that idea to help us on number 3 then. We want to go through and calculate these home runs using our explicit formula. 1 second. Okay, so if I want to hit 35 home runs, what that technically means is I want to find the 36th term. Okay, so the way that I write this up is Rico's formula is knowing the $125 for the starting term and the common difference. So this is the formula we're going to be using all throughout here for Rico. Okay, so if I want to find the 36th term, what I'm going to do then is go to plugging in 36 for n, and then go into my calculator and punching in 18 times 35 and then plus 125. When I go to my calculator and punch it in, what I then find for the answer is Rico's going to donate $755. So they're going to donate $755 if they hit 35 home runs. For 48 home runs, I use that same equation, that same formula, but when we're talking 49 home runs, we're really talking about the 49th term. So 125 plus 18, I keep using that. Okay, 1 second.